Okay, my dear students, once again, this is revisionug.com, science lesson number 2 under the theme matter. So our subtopic is about the forms of electricity. In the previous lessons, we looked at what electricity meant, and we said that electricity is a form of energy that just deals with what we call charges. We looked at charges such as the electrons, which charge negatively, then protons that charge positively, and the neutrons that are uncharged. So in this lesson, we are going to look at what we call the forms of electricity. Right, so the forms of electricity. Now there are just two forms of electricity, and one is what we call the current electricity. Then number 2, this is what we call the static electricity. Now we are going to look at one by one. In the previous lesson, under our terminologies, we looked at what we call the electric current, whereby we say that electric current, this is the flow of the charges. Then what we call current electricity, we are going to see this type of electricity where the charges are flowing. So current electricity is a form or a type, is a form of current electricity is a form of electricity. Let me write here. Is a form of electricity in which electrons flow, in which charges or electrons do flow, in which electrons flow. Just that is current electricity. Then the opposite of current electricity, that is static electricity. Therefore, static electricity is a form of energy, form of electricity in which charges do not flow. Form of electricity in which charges or the electrons do not flow. Do not flow. So we are going to look at one by one, and we are going to start with what we call the current electricity. Now this current electricity is being divided into two other subtypes, and one we have the DC and another one is called the AC. Then the DC in full stands for the direct current, and the AC stands for alternating current. The word is alternating current. That's why when you look at our heading, it is saying direct and alternating electricity. Now, so we have direct, that is DC, direct current, and we have the A and the C, that is A stands for alternating and C is for current. So those are the two forms of current electricity. In summary, we've said current electricity is a form of energy or form of electricity in which charges do flow, and those charges are the electrons. It is divided into two, that is the DC and AC. DC standing for direct current and AC is standing for alternating current. All right. Now at this moment in time, we are going to start with what we call the DC. We are now going to understand the DC fully in two details. Now DC, as we've said, it stands for the direct current. This one is direct, and then what is its definition? So direct current electricity is the form of current electricity in which electrons or in which charges flow in only one direction. So direct current, the charges flow in one direction. So it is the form of current electricity where or in which charges flow in only one direction. Now what is the direction? That is from the positive terminal and then going to the negative terminal, or from the appliance. It can flow from the appliance from the source then to the appliance. So it can flow from the source then to the appliance. For example, we can have our dry cell. This one can be the dry cell. It has positive and negative. Then here I have my bulb. It is attached onto the dry cell. I have my wire. So the current is going to flow from the negative terminal coming to the positive terminal. So it is flowing from the source, that is from the dry cell, then coming to the appliance. Appliance, that's the material which is using electricity. Okay, so I hope we are together. Now that is the DC. Now after we have looked at the definition of DC, direct current, we are going to look at the sources. the sources of direct current. Yes, sources of direct current. Now the sources of direct current, one, we have what we call electric cells. We have electric what? Cells. Then all electric cells are sources of DC. Then what are these electric cells? So electric cells are cells or devices that can store and that can produce and store current, electricity. So these are devices. These are devices that can produce, one, they produce, as well as storing, so that can produce and store current. Current, those are the charges. So those are the electric cells. So all electric cells are sources of DC or direct current. Now let us look at these electric cells. So these electric cells are further divided into two types. One, we have the primary cells, and number two, we have the secondary cells. Remember we said a cell or an electric cell, that is a device that can produce and store current, electricity. And then they are divided into two, that is primary cells and the secondary cells. All of these ones are the sources of direct current, meaning that their current flows from the terminal, positive terminal, then to the negative terminal, or it flows within one direction, that is from the source to the appliance. My dear candidate, let us now start with the primary cells. Then with the primary cells here, what are they? We are going to take brief characteristics about them. These cells are not rechargeable. So they are not rechargeable once they get exhausted. Number two, they are portable. Most of them are portable. And number three, they are not durable. So they are not long or lasting. In brief or in summary, a primary cell, it is that electric cell which is not rechargeable when it is now used up. Okay, now let us get examples of these primary cells. Examples of our primary cells. Number one, we are having what we call wet cells. Then number two, we have what we call the dry cells. So those are the two examples of primary cells. So the disadvantage with these primary cells is that they are not rechargeable, so they are portable, and again they are not durable. So we are having the sequence is dry cell, wet cell. They give us primary cells. Then primary cells are they are under electric cells. Electric cells, they are the sources of DC. Then DC is a form of current electricity, or it is current electricity. From current electricity, we have gone to the source, to the forms, that is the DC. Then from the DC, we have gone to the source, that is electric cells. From electric cells, we have now got primary and secondary cells. Then from there, we have looked at primary cells. They have given us wet cells as well as the dry cells. So those are the examples of what we call the primary cells. Then let us get an example of the wet cell here. The wet cell, as you are seeing here, these two are their wet cells. We have this one here, and also we have this. So we have to understand the parts that make up a wet cell. Now a wet cell is made up of various parts. One, it has the terminals, that is number one. We are going to look at the terminals it has. The number two, it has an electrolyte, the source of electricity. It has an electrolyte. Then it has the conducting wires. It has conducting wires. Now we are going to start with one by one. Let us start with what we call the terminals. Now the terminals of these wet cells, or a terminal, that is the point through which current enters and leaves the solution. So these are the positions. These are the positions through which current enters, and leaves the solution. Now those are the terminals, and these terminals, they are scientifically called electrodes. We call them electrodes. So meaning that what is an electrode? An electrode is a terminal through which current enters and leaves the solution. Now that's an electrode, and there are two. One, we have the positive electrode and negative electrode. Then the positive electrode is called an anode, so it is the anode. Then the negative electrode is called cathode. It's called cathode. So cathode is a negative electrode, then anode is a positive electrode. So an electrode is a terminal through which current enters and leaves the solution. Now we are going to look at another terminology here, that is an electrolyte. When we started this topic, we looked at a conductor, and we defined a conductor as a solid substance that can allow electric current to pass through it. Now that is a solid. Now in a case it's not a solid, it is a liquid. If it is a liquid, if it is molten, or if it is aqueous. We have these other states. It can be a liquid, it can be molten, it can be aqueous. Now if a substance is a liquid, it is a molten substance, it is an aqueous substance, and it allows current or electric current to pass through it, then it is called an electrolyte. Okay, let me write here the definition. I think we are still together. This is revisionug.com. New teacher today is teacher Hakim. Okay, now I will say that an electrolyte is a substance. It is a substance in molten, that is one, comma, it can be a liquid, comma, or aqueous. So aqueous. So is a substance in molten, liquid, or aqueous form. A form that can allow electric current. Remember we said electric current, that's the flow of charge. Electric current pass through it. Electric current pass through it. Like that. Now when we say aqueous, for example, okay, let us first get some examples here. Examples of electrolytes, then we understand how they work. Examples here, we have all mineral acids. All mineral acids. For example, mineral acids, we have a sulfuric acid. We have this one called sulfuric acid. Then we have organic acids such as citric acid. Actually, all acids. Then we have hydrochloric acid. So all acids conduct electricity in their aqueous solution. Mineral acids, dilute ones. Then we have all salty solutions. All salty solutions. For example, the table salt we use at home. Then when you get it, it is now a solid. Then when it cannot conduct electricity, or it cannot allow current pass through it. But again, when we dissolve water in it, it becomes aqueous. It becomes a solution, and it is aqueous while water has been added there. So that solution can allow current to pass through it. So after you have prepared that solution, then the solution becomes an electrolyte. So you dip in the electrodes, you connect the wires there, then we are going to see current flow through it. That is an electrolyte, and that is a weight what? A weight cell. Okay, now one thing we have to understand with these things is that when you look at these acids, especially the citric acid, you can get the lemons, you connect them, you do what? Then you see the bulb producing light. But again, if we go back to conductors, how they work, we say that these conductors have atoms. Then these atoms have protons and electrons, and the protons remain in the nucleus. Then we have the electrons, which make a cloud here, as we said. And we say that once a pressure pushes them, they are going to move through this. Then they move from part A, they come to part B. That's the conduction, or that's how conductors work, as we discussed earlier on. Now, these ones in solution form, for example, we are going to have our hydrochloric acid, we can use that one, HCl. Our hydrochloric acid, it is written as HCl. Now when we add their water, what's going to take place is this one. This one is going to break down. It's going to break down into hydrogen ions and chloride ions. Now these ones are the ions. Now in a conductor, that's the particles that carry current. We don't call them ions, but we call them electrons. They are the electrons. But the particles that are going to carry current within the solution of an electrolyte, then we are going to call them ions. It is IONS. So we are calling them ions. Now, for example, let us assume that this is our tin. This is our tin, or it's our beaker. Now in this beaker, we have put there a solution of water, and we have dissolved our salt, either the sodium chloride, that is our table salt, or we have added in our acid, and this acid is called HCl. Now this one becomes an electrolyte, but at your level we normally use what we call sulfuric acid. It is sulfuric. So even if this is U, it is not read as it is read as sulfuric. It is sulfuric acid, and if you look at its formula, it is H2SO4. Now when we add their water, you know what's going to happen? This one is going to break into the hydrogen ions and SO4, which we call the sulfate ions. So there are these things that are going to be in this solution here, which we call an electrolyte, and they are going to be they are going to keep on moving from one part to another, like that one, saturating. Then this one becomes our electrolyte. Then after that, we are going to dip in our electrodes. Now this is an electrode, and also this one is going to be an electrode. So this A and this B. So A plus B, the general name given to them, we call them the electrodes. But remember, we say that these electrodes, we have the positive one and the negative one. Now at our level, we normally use zinc. We use zinc, and also we use copper, pure copper. Now this copper acts as the positive terminal. Now if I put here positive, you just know that this positive terminal now, electrode B is now going to be scientifically called the anode, because we said the positive terminal is called anode. Then, meaning that now if I put here negative, therefore that negative terminal is now going to be termed as the cathode. Yes, this one is the cathode. Therefore, they can draw for you this one. They put AB, they put the charges, then they tell you to name them. So this positive one, it is the anode. Then the negative one is it's the cathode, right? Yes. Then they can ask for the material from which this one is made. Now this one is made out of zinc, and this one is made out of copper. Now from there we can connect our wires. Now when we connect our wires, this one is going to be our bulb. So the moment the wires are connected, then the bulb is going to produce light. So for further chemistry on how this one works, I will see another video which I'm going to make within our Revision UG laboratory. So you will see it when it is prepared, and you understand the chemistry between here. So these ones, we are having hydrogen ions, then we are having sulfate ions. Now these hydrogen ions, because they are positively charged, they are going to come here, then the sulfates are going to come here. So as they are moving from here, they come with that energy. On reaching here, on being attached here, then they release that energy, which is now going to move through the electrode, then it comes to the wire, then it passes through the bulb produces light, then they come back here. Now this one becomes direct current and is a weight cell. So this is the an electrolyte. These two are the electrodes. We have the positive and the negative. The positive one is an anode, then the negative one is called the cathode. So this is a weight cell. Now this weight cell, it has challenges. It has the challenges or the defects, the things that disturb it. One, there is what we call polarization. You have to get this one. We have polarization. And number two, there is what we call local action. Yes, we have local action. Now we are going to understand what polarization is. Now these two defects are going to make the disadvantage of using a wet cell. Let me write here the disadvantages. Now these ones are defects which are going to cause the disadvantage. Then the disadvantage of using this one is that it produces light shortly. Produces light shortly. Now they will ask you, why does it produce light shortly? Simply because there is polarization and local action. Now polarization, this is when let us write here polarization. Polarization is when bubbles of hydrogen gas block the copper rod or the copper terminal or the copper electrode, the copper rod. So when you look at these hydrogen ions, then they are going to come after they have gone here. They are going to release, they are going to pick an electron, then we get hydrogen, then when we get hydrogen and another hydrogen, we are going to make a hydrogen gas. So you are going to see this one practically when we do it in our revision UG laboratory. So now these bubbles are going to be here very many. Now when they are very many, they are now bubbles of hydrogen. Actually, in some cases, sometimes they can draw for you this. They name this one as X. They tell you to name the gas. So the gas which is here, that is the hydrogen gas. And again, the condition which is leading this one to be here, that condition is called the polarization, or the defect is called the polarization. Now when the hydrogen bubbles block this, it means that now the entry of more current is now blocked. Then this bulb is not going to receive that current, then it's going to go off. That's why we are saying using this wet cell is disadvantageous in a way that the bulb produces little light. Produces light for a short period of time. That is due to polarization. Then local action. This is when the impurities of zinc, block or contaminate the zinc rod. So we are seeing the impurities from the zinc rod. So when they are coming from the zinc, then they end up contaminating and making these ions move slowly. So as they are moving slowly, then they will not reach to the terminals on time. Then this one is going to dim out. As it is dimming, then eventually it will just go off. So local action, these are the impurities that do come from, it's caused due to impurities coming from zinc. And again, polarization, that's when we see bubbles of hydrogen gas blocking the copper rod or the copper electrode or the anode. Then another disadvantage of using wet cells is that it is bulky. Now imagine carrying all this big bottle with a bulb. You are going to the toilet, you are going to the market. It is very bulky, it's heavy. Number 3, it can only be used in upright position. It can only be used in upright position. So like the bulbs we are having hanging now on a ceiling, so this one cannot be put upside down. The moment it is like that, this one will pour. So once it pours, then it is of no use. So these are the disadvantages of using wet cells. 1, producing light shortly for a short period of time. It is bulky and it can only be used in upright position. The defects there, that is polarization and local action. Yes, that's that. For any inquiry, you can contact us on our social media platforms, our handles, then or on our revisionug.com websites. This is Teacher Hakim as usual. Keep up with revisionug.com. In this segment, I'm not going to leave an assignment, but the notes are going to be attached. So you copy the notes. If you don't understand, come back to the video, or else raise a complaint. We shall answer. We meet in the next lesson. That will be lesson number 3.